Dr. Sarah Mitchell had spent 15 years studying coral reef ecosystems, earned her PhD from James Cook University, and led marine research expeditions across the Indo-Pacific. When her team arrived in the Sulu Sea to study deep reef formations, she hired local support staff including Amadou, a Bajau fisherman who'd spent his entire life diving these waters. During the equipment briefing, Sarah explained the research protocol, using advanced diving gear, underwater cameras, and remote-operated vehicles to survey reefs at depths up to 40 meters. Amadou listened politely, then mentioned he could free-dive to those depths without equipment to help with sample collection or equipment recovery if needed. Sarah smiled with the patient condescension scientists reserve for well-meaning locals who don't understand technical limitations. Amadou, I appreciate the offer, but 40 meters is beyond safe freediving limits. Even trained technical divers need specialized equipment at those depths. The pressure, the nitrogen narcosis, the oxygen requirements, it's physiologically impossible for humans to work effectively at 40 meters on a single breath. That's why we have all this equipment. Amadou nodded but said nothing more. What Sarah didn't know was that Amadou was Bajau, part of a seafaring culture that had lived on and under the ocean for over 1,000 years. The Bajau, sometimes called sea nomads, had developed physiological adaptations for diving that scientists were only beginning to understand. Enlarged spleens that stored oxygenated blood, slower heart rates during dives, increased lung capacity, and genetic adaptations that allowed them to hold their breath and function at depths that would incapacitate most people. Amadou had been diving to 40 meters since he was 12 years old. By 40, he'd spent more time underwater than most marine biologists spent in laboratories. The research expedition began smoothly. Sarah's team deployed their ROVs, collected samples, documented coral formations using their advanced equipment. Amadou worked on the boat, helping with logistics, saying little. On the third day, they discovered something extraordinary, previously undocumented coral formation at 42 meters, a potential new species that could be critical for understanding reef resilience. Sarah needed to collect physical samples and take detailed photographs, but the ROV's manipulator arm malfunctioned when they tried to extract specimens. We need to send divers down, Sarah told her team. Full technical diving gear, mixed gas, the works. This could be a significant discovery. Her technical diving specialist, Marcus, prepared for the dive, triple-checking his rebreather, his gas mixtures, his dive computer. The preparation took 90 minutes. Meanwhile, the boat had drifted slightly, and relocating the exact formation was proving difficult. We need a marker at the site, Marcus said. Otherwise we might not find it again in this feasibility. Sarah looked at the depth reading. 42 meters, too deep for standard scuba, requiring technical equipment and extensive preparation time they'd already burned through. Amadou spoke quietly. Dr. Mitchell, I can put marker, go down, place it, come back. 5 minutes. Sarah turned, frustration evident. Amadou, I explained this. 42 meters is impossible for freediving. You'd need to hold your breath for over 3 minutes just for the descent and ascent, with no time for work. The pressure would cause nitrogen narcosis. The oxygen debt would cause hypoxia. It's not safe. It's not even theoretically possible, for she stopped because Amadou was already preparing, doing breathing exercises. His face calm and focused in a way that made Sarah suddenly uncertain. Dr. Mitchell, I am Bajau. My father dived to 50 meters. His father dived deeper. I do this since I am child. I place marker. You send your diver after, please trust. Every scientific instinct, Sarah had screamed. This was dangerous, irresponsible, impossible. But looking at Amadou's calm confidence, and knowing they were losing daylight, and might never relocate this formation, she made a decision she'd later realize changed her entire understanding of human physiology. 5 minutes. You place the marker, and come straight up. Nothing else. Understood. Amadou nodded, took the marker buoy, and without any equipment except a weight belt and a simple dive mask, he took 3 long deep breaths and slipped into the water. Sarah and her team watched the timer. Amadou disappeared below the surface, and Sarah immediately began second-guessing her decision. 30 seconds, 1 minute. She was already mentally preparing the accident report she'd have to file when Amadou didn't come up. 90 seconds. The depth here was 42 meters. Even descending would take over a minute. How could he possibly have time to work and ascend? 2 minutes. Sarah's hands were shaking. This was her fault. She'd let a local fisherman attempt something physiologically impossible, and he was going to die because she'd been too impatient to wait for proper technical diving preparation. 2 minutes 30 seconds. He should have surfaced by now, Marcus said, his face pale. Even if he just descended and came straight up, he should. Then Amadou's head broke the surface. Calm, breathing normally, giving a thumbs up. Marker is placed. Dr. Mitchell, exact location, on the formation you want to study. Sarah stared in disbelief. How? That's... You were down for 2 minutes 40 seconds, at 42 meters. That's impossible. The pressure, the oxygen, the... Amadou climbed back onto the boat, not even breathing heavily. I know these waters. I know how to dive them. My people, we do this every day. Marcus dove the site an hour later with technical gear. The marker was perfectly placed, exactly where they'd wanted it, and he reported something that shocked the team: evidence of recent human contact on the reef. Broken pieces of shell, disturbance patterns that looked like someone had been working there. Amadou had done more than place a marker. He'd collected preliminary samples, assessed the formation, and done underwater work that Marcus, with all his equipment, was struggling to replicate. Over the next week, Sarah watched Amadou repeatedly perform dives that her training said were impossible. 40 meters for 4 minutes, 45 meters for 3 minutes, working, collecting, observing, all on a single breath. One day, their most expensive piece of equipment, a $50,000 underwater camera, broke free from its housing during a storm and sank to the bottom at 48 meters. That's gone, Marcus said grimly. Too deep for our equipment, too risky to attempt recovery. Amadou looked at Sarah. I can get it. This time, Sarah didn't dismiss him. Amadou, 48 meters is... Can you really dive that deep safely? Amadou smiled. Dr. Mitchell, my uncle once dove to 60 meters to free a boat anchor. 48 is okay, but I need to prepare, maybe 10 minutes. This is deeper, more dangerous. I must be careful. Sarah watched as Amadou did breathing exercises she'd never seen before, a meditation-like focus that seemed to slow his entire metabolism. Then he slipped into the water and disappeared. 4 minutes this time. When he surfaced, he had the camera, intact, functional, irreplaceable. Sarah sat down heavily. Amadou, how? Every physiology textbook I've read says what you just did is impossible. The pressure at 48 meters is nearly 5 atmospheres. The oxygen debt alone should cause you to black out. How are you doing this? Amadou sat beside her, still catching his breath but looking far less taxed than any diver Sarah had seen returning from such depths. Dr. Mitchell, my people, we are Bajau. We live on ocean for maybe 1,000 years. Our bodies adapt. Our spleens grow bigger. They store blood with oxygen for when we dive. Our heart, it beats slower underwater, saves oxygen. Our lungs, bigger than normal. And we learn from children how to use our body efficiently underwater, how to swim with minimum energy, how to stay calm when pressure hurts, how to know when we must surface. This is not magic. This is adaptation, evolution, training from birth. You study ocean from boat with equipment. We study ocean by living in it with our bodies. Sarah spent the rest of the expedition studying Amadou as much as she studied the reefs. She took physiological measurements. His spleen was indeed enlarged. His lung capacity extraordinary. His heart rate during dives dropped to levels that would alarm any cardiac doctor. She documented his diving techniques, the meditation beforehand, the negative buoyancy descent that conserved energy, the economical movements that minimized oxygen consumption. She began to understand that what looked like impossible diving was actually highly sophisticated physiological adaptation combined with lifetime training. When she returned to Australia, Sarah did something that took courage. She published a paper titled Human Diving Adaptations in the Bajau People, Rethinking Physiological Limits of Breath-hold Diving. She detailed Amadou's dives, the depths and durations that exceeded accepted human capabilities, and presented evidence that the Bajau represented a population with measurable genetic and physiological adaptations for diving. The paper was controversial. Colleagues accused her of exaggeration, of unsafe research practices, of romanticizing indigenous peoples. But other researchers, intrigued, began studying Bajau populations. Within 3 years, genetic studies confirmed the Bajau had mutations in the PDE10A gene that resulted in larger spleens, a provable physiological adaptation for diving. Marine biology programs began including case studies of Bajau diving in their curricula, not as trivia but as examples of human adaptation to extreme environments. The impossible dives Sarah had witnessed were now understood as the result of genetic adaptation, cultural knowledge, and lifetime training, creating capabilities that Western diving science had declared impossible because it had never studied populations who'd lived underwater for generations. Sarah returned to the Sulu Sea 3 years later, this time not to study coral but to study Bajau, diving physiology with a team of anthropologists and physiologists. Amadou, now officially a research consultant rather than just a boat helper, taught them about Bajau, diving culture, the training that began at age 5, the spiritual connection to the ocean, the intergenerational knowledge about currents, pressure, danger signs, and survival techniques. Dr. Mitchell Amadou said one evening, "When you first came, you thought I did not understand science. But my people, we understand ocean science. You do not learn in university. We know how water moves, how pressure feels, how to read reef and current and weather. Different knowledge, not less knowledge. You had equipment and degrees. I had lifetime in water and 1,000 years of my people learning. Both science, both valuable." Sarah nodded, humbled Amadou. "I called your diving methods primitive. I said what you did was impossible. I was wrong on both counts. Your diving isn't primitive, it's adapted, it's sophisticated. It's the result of cultural evolution I was too arrogant to respect." Today, Sarah's research team works in partnership with Bajau communities, combining Western scientific equipment with Bajau diving expertise and traditional knowledge. Marine conservation programs in Southeast Asia now employ Bajau divers, not as unskilled labor but as expert consultants, whose knowledge of deep reef systems exceeds what any equipment can provide. And Sarah keeps a photo in her office. Amadou surfacing after a 48-meter dive, holding the camera everyone thought was lost, smiling with the quiet confidence of someone who knew his capabilities even when scientists said they were impossible. Below it, a quote she wrote, "I came to the Sulu Sea to study how life adapts to the ocean. Instead, I learned that humans had already adapted in ways my textbooks said were impossible, and I'd been too blind to see it until a Bajau fisherman dove deeper and longer than science said humans could, and came back up smiling to teach me that impossible often just means I haven't met the people who've been doing it for 1,000 years."